Okay, so this is the angles homework, and I'm just going to go over all the questions. Hopefully not making any mistakes, because I'm not going to do question by question. I can't get rid of this because I'm at home, but you just have to bear with. Here we go. Right, triangle PQR. PQR is an isosceles triangle, so it means that these two sides marked are the same length. It means that these two angles down here are the same. It tells you here that PQ is the same as PR, as I just said. Work out the answer to X. Now, it doesn't have to give any reasons, so we're away here. So I would always, in an exam situation, mark off angles I've found here, do any workings out neatly over here in the space provided or wherever it is on the exam sheet. It's an isosceles triangle, so the first thing I would tell the examiner is that I'm going to do 180, take away 48, and that's going to give me an answer of, well, 50 from that's 130, add 2 is 132 degrees. Okay, and because we know that this angle here is the same as this angle here, I've got to get this angle and halve it. So 132, I'll tell the examiner, divided by 2 gives you an answer of 65 plus that is 66. So 66 degrees. So at this stage I would mark it off 66 and 66. Now, because you've got angles on a straight line, I also know that 180 take away 66 is going to give you, well, 70 from there is 110 plus the 4 is 114 degrees. So therefore X is 114 degrees. Okay, right, next question. Explain why the sum of the interior angles of a quadrilateral is 360. Now, I'm not going to write all this down because it's very hard to with a mouse, but basically you will need to say, if you draw from any given vertex, so I'm going to pick on this one, draw a line, a straight line to the other vertices, you will know that it means you include one more line in. It gives you two triangles, and you know that the sum of the angles in each triangle, so the sum of these angles is 180, and the sum of these angles is 180, and therefore the sum of the interior angles must be two lots of 180. Okay, which is 360, and I'd obviously put that into words using the word vertex and describing exactly what I've done. Okay, question 2. ABCDE is a regular pentagon. Work out the value of the interior angle X. Okay, well, I'm going to use the law here that it's regular pentagon. Regular means that all these angles are the same, the interiors, and it's a pentagon, it's got 5 sides. So I'm just going to test you know this rule. This is just one way of doing it, it's not the only way of doing it. 5 sides, take away 2 tells you you've got 3 triangles. Okay, each triangle is worth 180, so 3 times 180, that's going to give you 540 degrees. And because all of these add up to 540 and all 5 angles are the same, you're going to do 540 and you're going to divide it by 5 to give you 108 degrees. So I suppose I would say therefore X equals 108 degrees. Okay, next question, part B. It says ABCD. So ABCD is a regular pentagon again. So we know that this here is 108 degrees, so I'm going to put that on there, 108. We know that this length is the same as this length. That's not the same, so what you've got is an isosceles triangle. So you know that these two bottom angles are the same. So the first thing you've got to do is the angles in the triangle out to 180, take away 108 from it, and you end up with 72 degrees. So you've got to share the two angles here. Divide that by 2 and it gives you 36 degrees. So therefore Y is equal to 36 degrees. Okay. Next question, number 3. The diagram shows part of a regular, again the word regular is important, polygon. Each interior angle is 162 degrees. Calculate the number of sides the polygon's got. Now, there are a number of ways of doing this, but the easiest way, if it's a regular, means that all the interior angles are 162. It also means that if you extend there, this exterior angle, it's a lot easier to use exterior angles when explaining this. So take that, first thing is 180, take away 162, well that's going to give you 18. Okay, so 18 degrees. So I know that that is 18. And I know a rule that says that the interior angles, the exterior angles, so exterior angles of a regular polygon is simply 360, because they all add up to 360, divided by the number of sides you've got. Now if I times through by that, just like in a trig, you times through by this and bring this down, you can rearrange this to get the number of sides is simply 360 divided by an exterior angle. So just one exterior angle. Okay, so n is equal to 360, and I'm dividing it by 18 because we know that one of the exterior angles is 18. If you work that out, you get 20 sides. Okay, and therefore do the calculation. Number of sides it's got is 20 sides. So just calculate the number of sides it's got. Job done. Question 4. It says in the diagram AB is parallel to AD, so you should already be thinking of three things, which are corresponding angles, alternate angles, and co-interior angles, and also vertically opposite angles. Okay, state the value of x giving a reason. So part A, the first thing I would say is x equals, and what it equals is simply the same as that because you've got two parallel lines here. I'll draw it on. You should know that this angle here is the same as this angle here, okay, because you're using parallel lines. So x is equal to 112 degrees, and the reason being it's corresponding angles. Corresponding angle. Okay, find the value of y, this one here. Well, there's no reasons need to be given here. It's a 2-mark question. Loads of ways of doing it. Just make sure you know, and it's quite obvious that that is not parallel to that. So I'm going to just put in as much information as I can find. So I'm going to rub this out here and put that there is 112 degrees. Now I know that this is vertically opposite, so that's 112 degrees there. I know that this is on a straight line here. So 112 take away 180 is going to give me 68. So I know that that is 68 degrees just there. And I know that I've got a quadrilateral here, and I know that the angles inside a quadrilateral add up to 360. So I'm going to add these up and take it from 360, and it'll give me y. So part B is I've got to do 112 added to 68 added to 130. Okay, so that's going to give me, add that to that gives you 180. 180 plus that is 310. So 310 degrees. Just check that again. That gives you 180. 200, 310. That's right. So therefore 360 take away 310 is equal to 50 degrees. So I know that y must equal 50 degrees. Okay. So that's that one done. Question 5. The diagram shows a regular octagon. Okay. Calculate the size of the exterior angle of the regular octagon marked y. Well, you know that that is simply 360 degrees. That's what all the exterior angles have to be. And if it's an octagon, it's got 8 exterior angles. So divide it by 8, and you will end up with, okay, so you could halve it and halve it and halve it again, or I'm going to use a calculator. 360 divided by 8, and that gives you 45 degrees. Okay, so therefore y is 45 degrees. Question 6. Again, you got this situation here. It's a regular pentagon. We've done this before. You know this is 108 degrees from previous. It's the same question actually, I think. You know that this is isosceles, so it's the same as that, and therefore these two angles are the same. So the working out again is the angles in a triangle is 180. Take it away from 108, and that will give you an answer of 72 degrees. And I know that these two angles must be the same, so therefore 72 needs to be shared between 2, which is 36 degrees. So we've done that before. X is 36 degrees, just in a previous question. Question 7. ABCDE is a regular pentagon. Calculate the size of each interior angle. We've just done that. you've got a number of sides. I suppose I'll do it long-winded. We've got 5, take away 2 gives you 3 triangles. 3 times 180 gives you 540, and therefore 540, and you've got 5 angles, so you've got to divide it by 5, and it gives you an answer of 108 degrees. Okay. Question 8. Calculate the size of an interior angle of a regular octagon. So regular octagon, an interior angle. Well, octagon's got 8 sides, so I've got 8, take away 2 equals 6 triangles. I do 6 times 180. Well, that gives you 6 80s are 480. So it's going to give you 1080. And then I'm going to do, because I've got 8 equal angles, I've got 1080 degrees is what they all add up to be, divided by 8 equal angles, and it gives me, and again I could halve it, etc., but I've got a calculator, why not use it? 1080 divided by 8, and it gives you 135. So 135 degrees. So calculate the size of an interior angle. So one interior angle would be that. Question 9. ABC is an isosceles triangle. So ABC is an isosceles triangle, and it says BCDE is a kite. Work out the value of x. Okay, so with a kite, you know that these two angles are the same. You've also got an isosceles triangle. It didn't even have to be an isosceles, but you've got 40 and 40 makes 80, and you know that this angle, therefore, looking at this big triangle just here, what I'm just outlining here, adds up to 180. I've got 2 of the angles, so 180 take away 80 gives you 100 degrees. So I would label that now and there 100 degrees. Okay, and because that's 100, and a kite means that this angle here is 100 degrees, because these opposite angles on the kite are equal. Okay, because it's got a line of symmetry going down here. Doesn't look it. And then we've got a quadrilateral. So I know that all the angles in a quadrilateral are 180. So therefore 100 plus 100 plus 40. Always write it down. Okay, 100 plus 100 plus 40 gives you 240 degrees. And I know that the out to 360. So 360 take away 240 gives you 120 degrees. Okay, so therefore x must be 120 degrees. Right, next question, number 10. It says the diagram shows a parallelogram ABCD. So ABCD, angle BAC, so B to A to C encloses the 20 degrees. Angle ADC, A to D to C encloses the 70 degrees. Show that the angle X is a right angle. So show that this is a right angle. Well, in a parallelogram, we've got this must be 70 degrees here. So you need to see here workings, how I usually set it out anyway, workings and your reason. Okay, so the workings is angle ABC, so angle ABC equals 70 degrees, and the reason you're given is as opposite angles in parallelogram are equal. Okay, right, next thing is you've got ABC is a triangle, adds up to 180, so therefore I can say that therefore x is equal to 90 degrees, which is what we're after, and the reason being is ABC, in fact triangle ABC adds up to 180 degrees, and that's what you've just done. You've added those together, taken away from 180 gives you 90. Now it says the area of the triangle ADC is 8.4 centimeters squared. Now what's going on here with the parallelogram is that you need to be aware that you've just worked out this area, or you've been told that this area here is 8.4 centimeters squared. Now what you've got isn't a line of symmetry, but you've got congruent triangles, identical triangles. That is the same as this triangle here, because that angle is the same as that, that angle is the same as that, and these are the same. So it's all the angles are the same and the lengths are the same, etc. So these are congruent triangles. So all I've got to do is work out the area of the parallelogram. I've got to just double that. Okay, so this is part A, and part B would simply say it is 2 lots of 8.4, which is going to give you 16.8, and it is centimeters squared. Okay, question 11. Work out the values of A, B and C. There's A, there's B, there's C. It's quite hard for me to see anyway. No reasons given. Well, dead easy. A is equal to, and we can see that these got parallel lines here. So these, as you should know, are alternate angles. So therefore A is 60 degrees. B, well, B is here, so I can put that as 60. And I know there's a number of ways of doing this, but I know that this is 70, therefore this is 70. And therefore the angles on the straight line are up to 180. So B is simply going to be 180, take away 70, which gives you 110 degrees. So I've got 110 degrees. And then finally C. Now whenever I've got one of these questions here where there's two lines meet in the middle, I always draw, in fact I always draw a line, or include a line here. Okay, so in fact I don't know what I'm doing there. Got to go to there and there. Right, draw a line here. Okay, right, and make sure that that is parallel to the rest of these. Now this entire angle C, you can see that this, because you've got this angle and this angle is alternate, I can say that that is 60 degrees. This is alternate, so that is 70 degrees. I can see that the entire angle C is the combination of these two. So therefore, there's a little trick there. Whenever you've got this situation, to draw a line in that is parallel, and it allows you to get these here. So 70 plus that is 130 degrees. Okay, so those are the answers there. Question 12. The diagram shows a regular decagon, so 10 sides. Work out the angle at the center of the decagon marked X on the diagram. Okay, well, you know that if I drew all of these in, so drew that, etc., then I'd have 10 lots of these around here. And going around in a full circle is 360. So all I've got to do is divide 360 by 10 to give me that answer there. So edit, undo. Let's just write that on. Part A, I know that that X is going around, as I said, 10 times. So therefore 360 divided by 10 makes 36 degrees. So X is equal to 36 degrees. Right, part B. It says work out the size of an interior angle marked here. Well, you could do 10 sides, take away 2, gives you 8, 8 times 180, etc. Well, you've just worked out, same thing here. It's got 10 sides, extend a line here, you know this is an exterior angle, it's a regular decagon. So 360 divided by 10 gives you 36. I also know that that is 36 degrees there. So that makes that angle there, and all these angles the same, as simply 180, it's on a straight line, take away 36, and that's going to give you 144 degrees. So therefore Y is equal to 144 degrees. Okay. Question 13. The diagram shows a hexagon. It's not a regular hexagon, obviously, by the looks of it, and the angles as well. The hexagon has two lines of symmetry as shown. Work out the value of X. Well, I know that that's an exterior angle there, so take it away from 180. So 180, take away 50 is equal to 130. Always worth showing your workings. Put it on here, 130. And because you've got a line of symmetry here, you know that x is also equal to the same, 130 degrees. Next thing here, they've drawn this line on here, so I'm going to extend this through. Y is that entire angle. They've done this bit here, so I know if that's 50, then that is 50. And because of symmetry, I know that that must be 50 because it's reflected. So therefore, y is simply equal to 50 plus 50 is 100 degrees, as I work out the value of y. Question 14. A regular polygon has 9 sides, so regular again. Calculate the size of the interior angle. Again, I'll do it this way. It is 9 sides take away 2. Gives you an answer of 7 triangles. So 7 triangles, 7 times 180. Okay, so I can't be bothered. 7 times 180 is equal to 7 times 180 is equal to 1260. Okay, so 1260. Right, so I end up with that 9 sides, they're all the same, so I've got to do simply 1260 divided by 9 equal angles gives you, okay, so there we go, divided by 9 equal angles, and it gives you 140 degrees. So we've got the answer there. Right, B, explain why there is no regular polygon which has an interior angle of 155. Now they're saying regular, so I would draw a little snippet of that. There it is, and I'd put 155 if it's regular. You know that that length is the same as that length, even though it doesn't kind of look like it. And if I extend this line on here, it means the exterior angle would have to be 180. Take away 155 gives you an answer of 5 to 60, 25 degrees. Okay, so that would be 25 degrees. Now remember, an exterior angle, remember if it's regular, they're all 25 degrees if it existed. So one exterior angle is equal to 360, because all the exterior angles are 360, divided by how many you've got. Well, that is n. Now n has got to be a whole number, it's got to be an integer. That's what a whole number is, an integer. Okay, if n isn't, it means that, because it's telling you how many number of sides it's got, if it's a decimal, then it just doesn't work. So again, change these around here, you end up with n, number of sides, is simply 360 divided by one of the exterior angles. Okay, so all we're going to do is now do n is equal to 360 divided by 25, and you'll see what it gives us now. So 360 divided by 25 equals, and you can see it's a decimal, you get 14.4. so number of sides is 14.4, therefore impossible. Okay, because n's got to be an integer. N stands for the number of sides, so you can't have 14.4. okay, that's not the only way of describing it, but that's the quickest way I feel. Right, the lines AB, and CD are parallel. Work out the value of x, giving a reason. Okay, this is a ridiculously easy question. You know that, again, x is simply equal to the same as this here, because these are alternate angles. It is 98 degrees, and that is because alternate angles. Alternate angles. Okay, and I think, yep, that's the test done. Okay, I hope that makes sense.